In the present video, we're going to talk about factorization. It's a very important operation in algebra, and we're going to start with this worksheet. To do a factorization using Maxima, we use the function factor. It works for numbers, like here factoring the number 488 is equal to 2 cubed times 61. Now we're going to factor this trinomial, which you may remember is the expansion of a binomial. So with the shift enter, it turns out to be x plus 1 squared. X squared minus y squared is equal to y plus x times y minus, x plus y times x minus y. The x minus y is presented by this term. Here we have another polynomial that we can factor in this manner. This one gets factored like this. This one gets factored like this, and this one gets factored like this. Factoring could be easy at times, could be complicated at times. You do it by hand, but with the function factor, it will help you out a lot. A perfect square. When you have a square of one term and two times the product of the squares plus the square of the second term, you get a perfect binomial square, and if you factor out, it gives you that result. Here's another example of a perfect binomial. Difference of squares will factor out into a sum and a difference. Here's some examples. Here's one where it is actually the sum and difference, but it is a complicated kind of binomials. Here's another factorization, and essentially the function factor is very good. It does the job all of the time. Factoring a trinomial of the form x squared plus bx plus c. If a factorable factor will give you that result. Basically, you're looking here for two terms that when you multiply them 7 times, they give you these terms, and when you add them, 7 plus 8 gives you this term. Here is a little bit more complicated. It's 24 plus 22. Here is even more complicated because the product should be 1008, but this is a fourth power, and so it gets factored like this. Let's try this one here. Shift enter. Shift enter. Shift enter. There's all these examples of factorization that are easily done with the factor function in Maxima. Factoring perfect cubes. Remember, if we expand the sum of cubes, the difference of cubes can be expanded like this. So we're going to get here another one. Differences of odd powers typically produce some sort of factorization, though we get a very complex polynomial right here. Here's factoring that produces 3 factors. Right. Now, what if we want to find the greatest common divisor of 2 or 3 polynomials? Let's define these polynomials right here, P1, P2, P3, and let's factor them by using factor and a list. And we can see there that there is this factor x squared minus 3x plus 9, x squared minus 3x plus 9, x squared minus 3x plus 9 in all of them. So that common factor could be the greatest common divisor. If you do shift enter here with the function GCD, we found indeed that that is the greatest common divisor. The greatest common divisor can be applied to numbers, but only in pairs. So if we're going to find the greatest common divisor of 81 and 27, we get it is 27, and the greatest common divisor of 18 and 180 is 18. So the greatest common divisor is that term that can divide all of the polynomials or all of the terms exactly. Here's another example. P1, P2, P3, and P4. We're trying to find a greatest common divisor among all of them, and it turns out to be a cubed plus a squared plus 1. If we want to check that, we can use this function called divide. And say we divide P1 by, we put P1 comma, then I'm going to copy these. Shift enter, and it says that the quotient is a minus 1 and the residual is 0. We can check with all of the others. I invite you to do that with the form. There's also the least common multiple. That would be the smallest term that is multiple of all the polynomials. We're going to define these polynomials right here and calculate the least common multiple. If we factor, I'm going to do here a factor of P1, P2, P3. We can see that there's x plus 3 here, and then there's the x squared minus 3x plus 9. So this is the common factor. That common factor shows up in there. Also the x plus 3, and then also the 2. And so the product of all those terms will produce the least common factor. Can be applied to numbers too, and in this case you can actually apply to more than 2. All right. So basically what I presented in this video and with this form is that the factor function is very important for factoring. There are rules, of course, that you may remember for factoring by hand, but if you have any doubt, use the function factor. And with this way we finish our video on factorization.